We are starting on section 5.6 today. In this lesson, we're going to be going over parallel and perpendicular lines and their relationships. Before we get to that, we have a mixed review here. I'd like you guys to go over that mixed review. Give me a second also, because I need to turn down my phone, but I'm also expecting a phone call. So I may have to pause if my phone rings as well. So right now, though, I'd like you to work on the mixed review. So number 1 and 2 here, just as kind of reviewing before we get going. So go ahead and pause it, do those 2 problems, and then you can check in a minute, okay? So here are the answers to the mixed review here. I went ahead and put the formula up at the top for point slope form, and I also put the 2 versions that you could have depending on whether you use the first point or the second point. I want to note also that I went ahead and put 1 here where your slope should be, but technically you don't really need a 1 here. You could just say y plus 1 equals x plus 2. But for our purposes, the 1 there is fine. I just think it's nice for you to know where the slope goes. So either of those answers works. In standard form, again, I put the formula here, and I went ahead and got rid of the fraction right away. So I multiplied every value by 2. And then I moved the x over. So if you want to leave the negative there, we would have this answer. Or if we don't want the negative in front of the x, we change all the signs. So that second answer would work as well. So just a little bit of review right here as we go through, continuing to review things that we've covered. Now, in this part, we're going to be talking today about parallel and perpendicular lines. So lines are parallel if they have the same slope and different y-intercepts. The graphs, for example, of these 2 equations are parallel because they both have a slope of 2, but they have different y-intercepts. One is -6, one is +3. So we know those lines would be parallel to each other if we were to graph them. So if we look at this example here, this example again is kind of already worked out, so you can have an example to look at as you are going through your problems. So here they want us to write an equation in slope-intercept form. So that's important to know. For the line that passes through this point, which 8, 7, and is parallel to this other line. So the thing to think about is we know if they're parallel to each other, they have to be the same slope. So since this slope is given as 3/4, we're going to use that slope of 3/4 in our new equation, and we're going to start with point slope form. So I'm going to take 3/4 and plug that in for my slope, and then I'm going to go up here and say, okay, it has to go through 8, 7. So we're going to plug in 8 for our y1 value and reverse that. 7 for the y1 value and the 8 for the x1 value. So that's what they're asking us to do here. We're substituting in the point and we're substituting in slope. Then we would simply use the distributive property. Excuse me. And we would then add 7 to each side. So we would end up with our equation 3/4 x plus 1. So that means this equation that goes through this given point would be parallel to this equation. They have different y-intercepts, same slope. so we know that they're parallel to each other. Moving to the next part here. So we can determine the relationship between two lines by comparing their slopes and their y-intercepts. So again, here is an example where they have the same slope, different y-intercepts, so we can see they're parallel to each other when we graph them. So when we write an equation, let's practice here. So again, they want the line to pass through this point, and they want it to be parallel to this line. So what equation represents this line in slope-intercept form? So if you remember here, it kind of goes through step by step what to do. So we'll start by using point-slope form. So I have to look here at my slope. So I know my slope is going to be 2 because they have to be parallel. And I know this is going to have to be my x1 and my y1 because it has to go through that point. So I'm just going to plug them into point slope form. So y minus y1, well, this is already a negative, so it's going to become plus 1. And then my slope is 2. And then I have x minus x1. Again, the negatives can't cancel or become positive. Now we want it to be in slope-intercept form, so we would use the distributive property. Y plus 1 equals 2x plus 6. And then we would subtract the 1 to give us y equals 2x plus 5. So this equation is parallel to this equation, but we can see they also have different y-intercepts. And we know that this line, if we were to graph it, would go through this point. So just using what we've learned so far, but also applying it to parallel lines. Now, we can also use slope to determine whether two lines are perpendicular. Perpendicular, of course, we use a little symbol kind of like this in geometry. This symbol, if my line was straighter, sometimes they have a little box here, like so. Just a second. Okay. I'm going to redo that because that was just not good. So if I draw a straight line, kind of that looks like a 90-degree angle, we use this symbol to mean perpendicular to. I should have mentioned earlier up here, parallel lines. We kind of use this symbol in geometry to represent parallel instead of having to write out the word all the time. So for perpendicular, we use this symbol. So perpendicular lines, of course, are lines that meet at a right angle. So in this case, we also need to talk a little bit about opposite reciprocals, because we're going to need to use those. Meant to be on my highlighter there. Let's try that again. So opposite reciprocals are slopes of perpendicular lines. They have to be opposite reciprocals of each other. So for example, 2, I always like to write it as 2 over 1, and negative 1/2 are opposite reciprocals. We have to flip the number, but we also have to have the opposite sign. So another example of that, let's say I have negative 2/3, and I want to have the opposite reciprocal of that because then they'll be perpendicular. So I would change this. The sign would have to become a positive, and I would also have to flip the fraction. So 3 over 2 would be the opposite reciprocal of negative 2/3. So when they are perpendicular, they have to have opposite reciprocal slopes. Okay? So moving on, here is another example that's kind of worked out, again, step by step, but it's not really in a table like the first one was, but you get the same idea. So now we want to know what is the equation in slope-intercept form when a line passes through this point, but is now perpendicular to this equation. So the first thing we need to do is look at the slope here and take the opposite reciprocal. So we would flip it and make it a negative. In that case, it would be -4 or -4/1, but we would just write that as -4. So -4 is going to be our opposite reciprocal slope to show that they're perpendicular. So same idea as the first problem now. We're going to start with point slope form. We're going to plug in 2 and 11 for x1 and y1, and we're going to plug in -4 for m. Then we're going to use distributive property. They kind of had a little typo there, but we'll deal. So they use the distributive property, and then we have to add the 11. So this would be our equation that has opposite reciprocal slopes, and that's how we know they're perpendicular. We don't really pay much attention to the y-intercept. We mostly just make sure that the slopes are opposite reciprocals and it goes through the point that is given. So there's another example worked out. So what we want to do again is classify. So are the graphs of these two equations parallel, perpendicular, or neither? So we have to find a way to compare those in the same way. So I'm going to take this second equation here and I'm going to put it into slope-intercept form so we can compare the slopes. So that means I've got to solve for y. So I'm going to just subtract the 4x to move it over to the other side here. So we have -3y equals -4x plus 9. And then I need to divide by -3 to all terms. So my new slope-intercept form, two negatives make a positive, so that's going to be 4/3 x, and that is going to be a -3 when we divide those. Now the question is, they can't be parallel because they're not the same slope, and they can't be perpendicular because they're not opposites. They are reciprocals, but they're not opposite reciprocals. So in this case, we would have to say neither or neither, depending on how you say that. So just a way to compare them in different forms and see if you can identify parallel, perpendicular, or neither. Okay, so I'm going to stop here for part 1, and then we have a couple more examples to do before you start your assignment.